We are moving on with Mathematics Paper 1 of November 2021. Let's start with question 6. It says the graph of fx equal to log 4x is drawn below. B, a point on the graph is k and 2. 6.1. Calculate the value of k. So we have fx is equal to log 4x with an x coordinate of k and a y value of 2. So I substitute f of x with 2 and x with k. Now I simply need to find k. So what it means is that the base of the log would become the base of the exponent. So k would be equal to 4 raised to the power of 2. Therefore k is equal to 16. 6.2. Determine the values of x for which f of x would be between -1 and 2. So in the equation of the graph, I would replace f of x with -1 and f of x with 2 to find the values of x for which this inequality is true. So first, -1 is equals to log 4x. So if I want to find x, I'll take the base of the log and make it the base of the exponent, and the exponent becomes -1. Therefore, x is equal to a quarter. And in the previous question, we found when the y value is equal to 2, that the x value would be equal to 16. So therefore, the values of x for which this inequality holds is x must be bigger or equal to a quarter, and x must be smaller or equal to 16. 6.3. Write down the equation of f -1, the inverse of f, in the form of y equal to. So in order to find the inverse function, I'll replace fx with y. Then for the inverse function, I simply need to swap the positions of x and y, and then solve for y in terms of x. So how I remove the log is I take the base of the log and make it the base of my exponent. So y would be equals to 4 to the power of x. So the inverse function of f is y equal to 4 to the power of x. 6.4. For which values of x will x times its inverse function be smaller than 0? So we have the inverse function as y is equals to 4 to the power of x. And if I draw a rough sketch of y equals to 4 to the power of x, I know that this inverse function would always be positive. What it means is that all the values of that inverse function would be above the x-axis. Therefore, the inverse function would always be bigger than 0. Also, what I can see is that this function does exist where x is smaller than 0, or when x is negative. So in this area, we know that the x values are negative and the inverse function is positive. And a negative times a positive is equal to a negative value. And that means that value is smaller than 0. But on the right-hand side of the y-axis, we can see that the x values are positive and the function is positive. And a positive times a positive value would always be positive or bigger than 0. So this inequality is only true where x is smaller than 0 or when x is negative.